Welcome to ET380. This is a lecture on basic electronic communication. One of the main components that we're going to study is transmitters. The transmitters are a collection of electronic components and circuits designed to convert the electrical signal to a signal suitable for transmission over a given communication. Here we have a basic AM transmitter. So we have an audio signal, preamplifier, AM modulator, which takes our intelligence, puts it on a modulated signal, and a power amplifier, and then an antenna which transmits. Here I'm showing a AM receiver, and this is a collection of electronic components and circuits that accepts a transmitted message from the channel and converts it back to form understandable by humans. So this is going to take our modulated AM signal and run it through an RF tuner, RF-IF converter, IF filter, and an AM demodulator and audio amplifier, and then puts that out as an audio signal, and we'll go into more of these components later. Okay, we have a couple kind of communication systems. This is simplex, where we have a one-way signal from, let's say, this is an example of a TV transmitter going through an antenna, our home picking up the antenna and going to our TV. So simplex means one direction, very simple. Okay, transceivers include both a transmitter and a receiver in one package. And this is half duplex communication. So we could talk or receive. We can't do both at the same time. So an example of this would be a walkie-talkie. You can't push the transmit button because you can't hear, or you could walk over the signal from someone else. So essentially we have a transmitter, receiver. On the other end we have a transmitter and receiver, and we could only use one of those internal components at a time. Next one is a full duplex communication. So we have two-way communication that's simultaneous. Example of this would be a telephone. So you could talk and listen at the same time, and the signals are separated. One of the other devices we're going to study is antennas, and they're not used in all communication systems. We have wiring and things. So this is a device that radiates the transmitted radio frequency, the carrier wave, and with intelligence riding on it, so it's some kind of a carrier and the main signal, and this is called an antenna. The high RF current in the antenna produces magnetic and electronic fields that travel long distance through space. With some systems use coaxial cables instead of that. So we're going to study several different types of antennas and do the analysis on those. So we have attenuation. Signal attenuation or degradation is inevitable no matter what the medium of transmission. Attenuation is proportional to the square of the distance between the transmitter and receiver. Media are also frequency selective in that a given medium will act as a low-pass filter to a transmitted signal. Distorting signal pulses in addition to greatly reducing the signal amplitude over long distance. And noise is a problem for our communication system. So any random undesirable electronic energy that enters a communication system. So we have a transmitter, whatever the medium is, and then we're inputting noise, and there's several different types of noise. Noise comes in two types, external and internal. So external would be atmospheric noise, static, lightning, dry wind, charged clouds, space noise, solar flux, sunspots, solar flares. So external noise, we have an 11-year cycle of sun activity. So sunspot activity recorded for past 300 years. So in 1907, we only had 60 sunspots. In 1958, we had 200 plus, and our average 120. So solar flux index is recorded continuously. We also have cosmic noise, star noise, coming from all the stars in all directions at all times. So we have a very wide band and very low frequency to X-ray, mostly 8 megahertz to 1.5 gigahertz. On Earth, 8 to 20 megahertz of cosmic noise blocked by the ionosphere. We have also man-made noise, electromagnetic interference from motors, generators, ignitions, etc. We also get corona discharge and interference from high voltage lines and fluorescent systems. We also have internal noise. It consists of random noise across the entire frequency spectrum. So we have two main categories: thermal noise, called agitation white or Johnson noise, and then shot noise because it sounds like lead shot poured on metal. Here's a chart of electromagnetic spectrum. So radio waves run from about 300 kilohertz to 3 terahertz. And we have medium frequency, high frequency, very high frequency, ultra high frequency, super high frequency, and extreme high frequency. We also have our visible light and optical spectrum, infrared through ultraviolet.